In this question, we have to establish Einstein's mass-energy relationship.
So this is the derivation of the famous formula, a famous equation of the energy. No, E equals mc squared by Einstein. So
Write down the expression for the relativistic mass. Relativistic mass is given as rest mass upon root 1 minus v square upon c square. Square both the terms, we will get.
so I am not very good in physics, but I do understand a little bit. So okay.
M square is equal to n0 square upon 1 minus v square upon c square, which
So this thing here is the I don't know what is this, but I guess this is the I don't know where did he get this, but I think 1 minus the velocity of a moving object or moving mass squared over the square of the speed of light. What is it? Is it a this say it is a ano? I don't know.
can be written as m square into 1 minus v square upon c square
Okay.
is equal to
So
m0 square, or m square c square minus m square v square is equal to m0 square c square. Now differentiate this equation. We will get
can I
2m.
first? I want to get the first equation.
In this question, we have to establish Einstein's mass-energy relationship. Write down the expression for the relativistic mass. Relativistic mass is given as rest mass upon root 1 minus v square upon c square.
So this is the M. There is a moving mass, and M initial or M sub naught is a initial mass which is not moving, and divided by the square root of a difference of 1 minus the velocity of that moving mass over the speed of light squared. So that is the mass of a moving object. Okay. So I don't know that.
Square both the terms m square 2v
he is doing the math.
dv, and this term is constant, therefore this equals to 0. Divide this expression where 2v, you will get 2
Where did he get dm? Is it
m0 square c square. Now differentiate this equation.
Differentiate.
We will get
2m
2m c square dm
so c squared there is a
minus,
constant. This cannot be
differentiate
derived, or
it.
it is just a constant.
You will get
So
2m v square dm minus m square 2
So it is assumed that the velocity is constant.
v dv, and this term is constant.
dv. So okay. So velocity is not constant. Yeah. Velocity is not constant. It is accelerating. I guess the mass is accelerating. I don't know.
Therefore, this equals to 0. Divide this expression with 2m. We will get c square dm minus v square dm minus mv dv equal to 0.
So what he's doing here is he's dividing the common terms, which is the mass, the m's here, since 0. Okay, so that is the simplified equation.
Or this can be written as c square dm is equal to v square dm plus mv dv. Equation 1.
Equation 1.
Now kinetic energy dk, small increase in kinetic energy,
Okay, differential
is
kinetic
equal
energy.
to the work done in increasing the speed from v to v plus dv. Therefore, it is equal to the work done to increase the speed from v to dv.
What? The differential kinetic energy is equal to the differential work. Okay. So kinetic energy is work. Therefore, if we differentiate work, is the same as differentiating kinetic energy, and that is the force. No, that's force times FD. The work is force times distance, and S is distance there, diba? Right? So he is differentiating the distance also, which is the change of distance. Okay, now I understand.
F is the force.
Since distance is changing, so that is the derivative of distance. Okay, correct me if I'm wrong.
From Newton's second law, force is equal to rate of change of
Position.
momentum
Momentum.
with respect to time.
Force.
D.
Force is a rate of change of momentum. Rate of change of momentum. I wish I had this kind of physics back when I was first year, but I am unlucky not to have a good teacher.
Upon dt, and momentum is equal to mv,
I do not have a good teacher.
which can be written as m dv upon dt plus v dm upon dt. Put this value of f in this equation. We will get kinetic energy dk is equal to m dv upon dt multiplied by ds plus v dm
multiplied by
upon dt into ds.
Therefore,
now this can be written as m ds upon dt v ds upon dt into
and this dt
dm.
is a velocity.
ds upon dt is velocity of the body.
Yeah, this is velocity.
Therefore, it is equal to v. So
mv
dv
dv
plus v square dm. This is equation 2. From equation 1, this expression is equal to c square dm. Therefore, kinetic from equation 1.
So equation number 2 is this one. Is it the same with c squared dm? mv? Yep, the same. The same.
This expression is equal to c square dm. Therefore, kinetic energy dk is equal to c square dm.
Yan? Okay.
Now integrate this equation. Kinetic energy from
So integrate.
0 to
We have the
k
differential equation.
and rest mass when kinetic energy is 0.
Okay. So remember, kinetic energy is an energy in moving. So is a moving energy or an energy in motion. So we have a differential equation. He is going to integrate to get the value of k, which is the value of E equals E. K equals E. Energy. And I saw the picture now. This is becomes E and this become M and C squared.
Mass is
Genius.
equal to rest mass. And when kinetic energy is k, mass is m. Therefore, k is equal to c square m minus m0.
Yep.
Now, total energy E is equal to kinetic energy plus rest mass energy. Therefore, c square m minus m0 plus m0 c square, which is equal to mc square.
What? E equals K plus M0 C squared. Energy, total energy is the kinetic energy in motion plus the energy. I don't understand why E is equals to the kinetic energy plus the product of the initial energy times the speed of light squared. Where did you get this one? M sub 0 C squared. I know this is a I don't get why. Where did you get this? I don't get where did you get this in the first place. But let's continue the video. So there is
E equal to mc square.
Wow, very nice. Differential equations, algebra need to be studied, and I'm not good